Astronomers are exploring whether extraterrestrial civilizations might leave clues such as chlorofluorocarbons in planetary atmospheres, waste heat from industrial activities, or artificial bursts of neutrinos or gravitational waves. They aim to expand the nearly 60-year-old search for alien radio signals to include these other potential indicators. These indicators, which might also include unusual chemicals in exoplanet atmospheres or signals suggesting alien megastructures, are collectively called technosignatures. The term was coined by Jill Tarter, a pioneer in the search for extraterrestrial intelligence, SETI. When astrobiologists began discussing biosignatures, the idea of technosignatures just naturally followed, Tarter told GeekWire at the American Astronomical Society's winter meeting in Seattle. Strange new discovery in orbit around a distant star. Exoplanets are fairly common throughout the universe, but astronomers recently discovered something truly perplexing in orbit around a distant star. This new extrasolar find has so far eluded any plausible explanation. Welcome to Matter. What exactly have astronomers detected in orbit around this star? Could it be evidence of an advanced alien civilization? Typically, the process of discovering exoplanets is slow and painstaking. Astronomers must sift through enormous amounts of data, meticulously measuring the observed brightness of stars over time. With a bit of luck, they might notice a star's brightness suddenly decrease and then return to normal shortly after. This temporary dip in luminosity suggests that something, perhaps a planet, is momentarily blocking some of the star's light. However, such observations are often insufficient to confirm the presence of a planet. Sometimes the decrease in brightness is too minor to distinguish from background noise. Data errors, unusual stellar activity, and other factors can also produce false positives and incorrect detections. Consequently, astronomers prefer to wait for the candidate planet to complete at least one more orbit, providing multiple transit events to analyze. By observing several transits of the same planet, scientists can improve their chances of confirming its existence and make more precise calculations of the planet's physical and orbital characteristics. To date, approximately 80% of all exoplanet discoveries have been made using this transit method. Although the transit method is the most effective technique we currently have for detecting exoplanets, it is not an easy process. For most extrasolar transit events, the parent star's brightness only diminishes by a tiny fraction of a percent. Extremely sensitive telescopes and equipment are required to observe these minuscule changes. Otherwise, the transit could go entirely unnoticed. In the recent case of the baffling discovery around the distant star, the observed phenomena defy easy categorization, prompting speculation about advanced alien civilizations. This discovery underscores the complexities and challenges inherent in the search for exoplanets and the potential for unexpected findings. Unprecedented dips in brightness. In 2015, while analyzing data from the now-retired Kepler Space Telescope, astronomers stumbled upon an extraordinary discovery. Unlike the typical 1% dips in brightness associated with exoplanet transits, they observed something far more dramatic with the star KIC 846282, commonly known as Tabby's star. On March 5, 2011, this star experienced a sudden and unprecedented drop in brightness by an astounding 15%. This was not an isolated event. In February 2013, Tabby's star exhibited an even larger dip, with its brightness decreasing by an incredible 22%. A mere month and a half later, a third transit was recorded, resulting in an 8% reduction in the star's light. Usually, subsequent transits of an exoplanet are consistent in depth and occur at predictable intervals based on the planet's orbit. However, the transits of Tabby's star defied these norms, displaying no discernible pattern in terms of transit depths or timing. Astronomers attempted to predict another significant transit for February 2015. Unfortunately, the Kepler Space Telescope ceased operations before they could verify their predictions, leaving the mystery unresolved. The peculiar behavior of Tabby's star remains one of the greatest astronomical puzzles of our time. The true cause of these sudden and substantial drops in brightness remains largely unexplained. To produce such significant reductions in luminosity, whatever is obscuring the light from Tabby's star would need to cover at least half of the star's visible disk. This fact rules out the possibility of a planet, as it would be far too large to be consistent with the observed data. Speculations have ranged from cometary swarms to large structures of dust and gas, but none have provided a satisfactory explanation. Alien megastructures or natural phenomena. One of the most thrilling theories, popularized by numerous news outlets shortly after the discovery, suggested that the dimming of Tabby's star might be caused by an enormous megastructure built by an extraterrestrial civilization. This hypothetical structure could be akin to a Dyson swarm, which is designed to nearly completely envelop a star, allowing the civilization to harness a significant portion of the star's energy output. The possibility of such an advanced alien megastructure naturally captured the public's imagination. Could the mysterious dimming of Tabby's star be the first definitive evidence of an alien civilization? This tantalizing question drew the attention of the SETI, Search for Extraterrestrial Intelligence Institute. In response, SETI conducted several extensive surveys of the region surrounding Tabby's star using the world's most powerful radio telescopes. Despite these thorough investigations, none of the surveys detected any signals that could be attributed to alien technology. While this lack of evidence did not entirely dismiss the alien megastructure hypothesis, many astronomers have approached it with healthy skepticism, favoring more plausible natural explanations. Although Tabby's star is unlikely to host an alien civilization, it remains an astronomical enigma. Several other theories have been proposed to explain the unusual light fluctuations of Tabby's star. One hypothesis suggests the presence of a circumstellar ring of dust, while another posits a large cloud of comets being torn apart as they pass close to the star. There is also the possibility of a planet being slowly consumed by the star. However, none of these theories have been able to comprehensively explain all aspects of the strange transits observed. Astronomers have kept a close watch on Tabby's star for several years, hoping to gather more data that might help solve the mystery. Despite the lack of a definitive explanation, the enigmatic behavior of Tabby's star continues to intrigue and challenge the scientific community. Role of wavelength-dependent dimming. In 2017, astronomers finally caught a lucky break in their investigation of Tabby's star. Dr. Tabby S. Boyajian, the star's namesake, along with her colleagues, observed a slight dimming of the star. They quickly alerted the global astronomical community, prompting dozens of observatories worldwide to monitor the event. This particular transit lasted about 3 days and resulted in a 2% decrease in the star's brightness. During this fortuitous event, observations were conducted across a wide range of wavelengths in the electromagnetic spectrum to gather as much data as possible. Over the next year, 6 additional fluctuations were recorded, with the most significant showing a brightness drop of at least 5%. After careful analysis, Dr. Boyajian's team made a crucial discovery. The dimming of Tabby's star was wavelength-dependent. This meant that whatever was causing the dimming blocked certain wavelengths of light while allowing others to pass through. This finding cast further doubt on the theory that an alien megastructure was responsible for the star's unusual behavior. Dr. Boyajian explained, if a solid, opaque object, like a megastructure, were passing in front of the star, it would block out light equally at all colors. This is contrary to what we observe. Thus, the likelihood of an alien civilization being the cause diminished. But the question remained, what exactly was causing the dimming of Tabby's star? While the precise nature of the phenomenon is still uncertain, the 2017 and 2018 transits provided valuable insights. The fact that the star dims unequally across different wavelengths aligns with the characteristics of space dust. Tiny dust particles, even smaller than the microscopic particles found in cigarette smoke, might be clumping together in vast clouds surrounding the star. These clouds could absorb some wavelengths of light while scattering others. However, this explanation opens up another mystery: the origin of such large quantities of dust. The exact source of the dust and how it accumulates around Tabby's star remains unknown. While the role of dust offers a plausible explanation for the observed wavelength-dependent dimming, the full story behind the enigmatic behavior of Tabby's star continues to elude scientists, keeping this stellar mystery alive and compelling. Gas giants, asteroids, and orphan exomoons. The enigmatic behavior of Tabby's star has led to a variety of fascinating theories, each attempting to explain the unusual dimming events observed. One hypothesis suggests that the star is orbited by a gas giant planet with exceptionally large and fluctuating rings. These rings could cause the star's brightness to dip in irregular patterns as they move in and out of the line of sight from Earth. Another intriguing idea is that a planet in orbit around Tabby's star might be accompanied by a swarm of asteroids. These asteroids could intermittently block the star's light, leading to the observed fluctuations in brightness. However, spectroscopic analysis of the star has shown that there is no material close to the star, and that all the detected dust is very cold and far away. This likely rules out the possibility that the transits are caused by an exploding planet, as such an event would generate significant material near the star. In 2019, a new study introduced a different and compelling theory. The fluctuations of Tabby's star might be caused by orphan exomoons. The researchers used numerical simulations to model the migration of gas giant exoplanets and their moons shortly after formation. The simulations revealed that in approximately 50% of the scenarios, tidal interactions could eject a newly formed exomoon from orbit around its parent planet. These orphaned exomoons would then become small planets on their own. If these exomoons are rich in volatile compounds, such as water ice, methane, or ammonia, they would be significantly affected by solar radiation, especially during the chaotic period of their migration and ejection. The radiation from the star might cause the volatile materials on the surfaces of the ejected exomoons to sublimate and drift into space, forming a diffuse, gaseous envelope around them. The simulations indicated that these hypothetical orphaned moons, with their evaporating surfaces, could produce light signatures similar to those observed with Tabby's star. This theory provides a plausible explanation for the wavelength-dependent dimming, as the sublimating materials would affect different wavelengths of light unequally. While the mystery of Tabby's star has not yet been definitively solved, astronomers have uncovered significant clues along the way. It seems unlikely that the strange transits are evidence of an interstellar civilization, but that doesn't diminish the importance of this discovery. Tabby's star remains an anomaly, suggesting there are aspects of planetary and moon formation that we do not yet fully understand.